Bismillahirrahmanirrahim. Assalamualaikum and good day. In this video, I'm going to explain the next topic, which is the approximation Poisson to binomial. So here means that the random variable originally from binomial distribution, but now instead of using binomial, we will use Poisson distribution. But first, we have to check whether the binomial has fulfilled the approximation properties. So the things that we need to note is the n, or the number of experiment or trials, is large enough, and the p is small. So how large in this term is n at least 30, okay, greater than or equal 30, and then p is small, which is 10 to 0, or it is much less than 0.1. So here is greater than 30 or equal to 30, but some reference may state as greater than 50. So we follow this one, okay, greater than or at least 30. So if these two n and p is fulfilled, then we can use the Poisson distribution instead of binomial. So from the binomial distribution, okay, we write this way: x distributed as binomial n and p. So now we switch to the Poisson. So because Poisson has mu here, which is the mean, so we need to compute the mean. So mean is taking from the binomial distribution formula, which is mu equal to n multiplied by p. Okay, let's look at this example. Suppose a life insurance company insured the lives of 5,000 men aged 42. So now the n is 5,000, and then the probability, okay, the 42 years old man will die in a given year is 0.001. So this is the probability of success. This is the probability of die, but because we want to find the probability of the claim by the insured, so now the die will become the success. So means here die is negative thing, but we say it is as success because that one is the probability that we want to find or calculate. So here means that the number of trials, or n, is large enough. It is 5,000, and then the p is small enough, okay, it is less than 0.1. So now instead of using the binomial, okay, the binomial is n 5,000, and then the p 0.001. Okay, first we try to use the binomial. Okay, as usual, x now is equal to 4, and then we substitute the p and q into the binomial formula, so we get the probability of getting success equal to 4. Okay, now we try to use the Poisson distribution. Okay, first we have to find the mean, okay, n multiplied by p, so mu is 5. So now we use the Poisson formula, mu equal to 5, x equal to 4. So now we get the answer 0.17546. So these two value is very nearly the same. So this is just to show you that we can use either binomial or Poisson, but when the approximation assumption is fulfilled, so we should use the Poisson instead of the binomial, even the answer will be nearly the same. So you need to be careful when there is binomial distribution, so you have to check whether the n and p is fulfill the assumption. So if we can use the approximation, so we must use the approximation. So after this, we also have another approximation, which is normal to binomial. So this is for Poisson to binomial.